Alright, so this is 1-1 notes. It's combining like terms and simplifying expressions. The vocabulary is already posted on here. So if you are not here or absent, you can copy that down. Just a quick overview, like terms, they're terms that contain the same variables. So for example, it would be 2x and 3x. Those are like terms because they both contain the variable x. If you had 3y and negative 5y, those would be like terms because they both contain a y. Simplest form, an expression is in simplest form when it's replaced by an equivalent expression having no like terms or parentheses. So what we're about to do in the examples is putting all of these expressions into simplest form. So I'll show you that example in a second. Coefficient, it's the numerical factor of a term. What that means is it's just the number that's in front of your variable. So if I had 3x, my coefficient is 3. If I had 144 XYZ, my coefficient is just 144. It's just whatever number is in front of all those crazy letters. And the last one, the question was, what is the difference between an expression and an equation? An equation has an equal sign, so that's why equate and equal. They both have the EQA that I have highlighted there. An expression does not have an equal sign with it. So what we're going to do is a couple examples here. So the instructions say simplify each expression. If it's not possible, you're going to write simplified. So for number 1 here, we have 12a minus a. So what I'm going to do is I'm going to highlight my variable here. My variable is the letter a. So you ask yourself, is this the same variable? If it is, then I can combine my like terms. I can write this in the simplest form. And it is. This equation would be something like I had 12 apples and my baby ate 1 apple. So how many apples do I have left? Okay. The thing that most kids forget is that this a means you have 1a. So if I were to simplify this, I would have 12 apples. My baby ate 1, so how many apples do I have left? Well, 12 minus 1 is 11, so 12a minus 1a is 11a. I would have 11 apples left. All right, number 2. And again, this is a video, so you can pause it. You can watch as many times as you need to if I go too fast. Number 2, you have 3x plus 6x. So here, my variable is x. Okay, so now what I'm going to do is I'm going to combine my like terms. So if I had 3 x's and I'm adding 6 x's to it, how many x's do you have total? You have 9x. Okay, so 3 plus 6 is 9. 3x plus 6x would give you 9x. Number 3, we have 3x minus 1. Okay, so I'm going to go ahead and highlight my variable here. I have an x. Now, here's the problem. That 1 doesn't have an x, so I can't simplify this. In order to simplify, you have to have the same terms, which means the same letters. Okay, so here you have 3x minus 1. So what this means would be like I had 3 apples and I take away 1, nothing. That doesn't even make sense. I don't even have a variable there to say I'm taking away anything. So here we cannot simplify it. This is in the simplest form. So what we write for our answer is simplified. All right, number 4. Okay, so I'm going to go ahead and highlight the variables that I see in my expression. So I have 20a, so there's a variable, plus 12a, so there's a variable, minus 8. All right, so what I'm going to do here is I know that I can combine these two because those have a variable with them. So what that means is I have 20 apples and I'm adding 12 apples to that 20, or you can just say 20a plus 12a. What does that give you? And whenever we add those together, 20 plus 12, whoops, did not want to do that. 20 plus 12 will give me 32, so I have 32 apples, and then, or 32a, and then I just have this minus 8 that's hanging out here by itself. It doesn't have any variable with it, which means it doesn't have a letter to be able to combine with that, so I'm just going to put here that I have minus 8. All right, number 5. Okay, I'm going to go ahead and highlight my variables that I see in my expression. So 3z, so there, plus 2z, so there's my other variable. How can I reduce this? So I have 3 of these letter z's. I'm adding 2 of these letter z's. And remember, z can represent anything. I can represent shoes, cell phones, pencils, pens. It doesn't matter. Z is just a variable for something. So I have 3 of these z's, and I'm adding 2 of these z's with it. How many do I have total? Well, 3 plus 2 gives me 5. So 3z plus 2z will give me 5 of these z's. Right, number 6, so I'm going to read my expression and highlight my variables. I have negative 6x plus I have 3d plus 10d. Okay, so notice I changed my colors here, and the reason why is because my variables are different. So for this first one, I have negative 6x, and then there's no other x's. I didn't highlight anything else in that pink reddish color, so that just drops right on down. There's nothing that I can combine with that, so I just bring it on down. But then what I notice is that I have positive 3d and positive 10d. So I have what we can call donuts. You have 3 donuts, and I'm adding 10 donuts to that. So how many donuts do we have total? You would have 13 donuts. Okay, so back in mathematical terms, 3d plus 10d will just give me 13d. All right, and it looks like we have one more row here. Okay, so number 7. I'm going to read my expression and highlight my variables. I have 2p, so there's a p, plus 1/2 q, so there's a q. All right, so whenever I look at this, my goal is to combine my like terms. Okay, so my goal here is I'm looking for whatever I highlighted, my terms. I need to make sure I have another one to be able to combine it with. I don't have any other p's, I don't have any other q's, I cannot combine these, so I'm going to put here, this is simplified. All right, number 8. Okay, so here, this one we have a little bit more work we have to do because we have 10x minus 4 times the sum of y plus x. So I have to get rid of those parentheses. So what I'm going to do here is I'm going to distribute this negative 4 to the y and to the x. So when I do that, I'll have 10x minus 4y plus 4x. Okay, so all I did is I distributed the negative 4 to the y and to the x. And since it's just a coefficient of 1 in front of the y and a coefficient of 1 in front of the x, negative 4 times 1y is negative 4y. Negative 4 times 1x is just, oh, I put positive. I'm glad I went through this. Is a negative 4x. Okay, so now what I'm going to do is I'm going to highlight my variables. So here I have an x. This one here is a y. So I'm going to change my color. And then I have another x hanging out back here. Okay, so what I'm going to do is I can combine my x's. So I have 10 x's right here, and I am taking away 4 x's. So 10 minus 4 is 6. Don't forget the x. And then I have this lovely 4y, negative 4y, excuse me, all by itself. So I'm just going to bring that on down, minus 4y. And usually kids ask, does it matter which one I put first, the x or the y? Typically what you'll see is that they like to go in alphabetical order. So x comes before y, so that's why I put 6x first. Alright, last one like this, number 9. So I have 21a, so I'm going to highlight a, plus 18a, I'm going to highlight my a. Then I have plus 31b, that's a different letter, so I'm going to, or different term, so I'm going to go ahead and highlight that, minus 3b. So I'm going to go ahead and highlight my b. So all this is saying is I'm going to combine these two because they both have that variable a in it. So whenever I combine these, I have 21 plus 18, and that's going to give me 39a. And then I have 31b minus 3b, and when I combine those, that's just going to give me 31 minus 3 is 28, and that's going to be the letter b. And that's how you write your simplest form. All right, let's see, and then the last little part, we just have some more problems here. So it says, in a recent year, the median salary for an engineer in the United States was $55,000. The median salary for a computer programmer was $52,000. Write and evaluate an expression to estimate the total cost for a business to employ an engineer and a programmer for 5 years. Okay, so what we have to do here is first we're going to look at an engineer. So the median salary for an engineer in the United States was $55,000. So I'm going to go ahead, I'm going to write that down. So for an engineer, we will have $55,000. Okay, then it says for a computer programmer, it's going to be $52,000. So I'm going to just put here, not with that. Let me get my pencil ready. So here I'm just going to put CP for computer programmer. That was $52,000. Okay, now it says write and evaluate. So we have to write and evaluate an expression to estimate the total cost for, you see, first I'm going to highlight this, write and evaluate. That means we got to do two things. Total cost for a business to employ an engineer and, that's another keyword, programmer for 5 years. Okay, so we're looking at this 5 years. Did not mean to do that. I need my highlighter. For 5 years. So what that means is I got to say how much does it cost for an engineer for 5 years? How much does it cost for a computer programmer for 5 years? And then what is the total cost that company will be spending? So what I'm going to do here is I'm going to write my expression. So first I'm going to start off with my $55,000. So $55,000. We're going to keep that person for 5 years. Plus, so let's see, I could do like in the orange, okay? Plus, we have my computer programmer who gets $52,000 a year, and again, we're keeping them for 5 years. So how much money would this cost the company to have both these? So for an engineer, whenever you multiply this out, for an engineer, they would get $275,000. Okay, for a computer programmer, they would get $260,000. So $260,000. So whenever we add both of these together, it would cost them, let's see, so we're going to have 30513. Okay, so we'll have $535,000. So a little over $500,000 it would cost to have both the engineer and computer programmer for 5 years at this company. All right. And the last one, find the perimeter of the fenced dog pen below. So for this one, what you have to understand is that this is a rectangle. So you have to have a little geometry lesson. Rectangle opposite sides are congruent. So that means if this top side is 2x plus 5y minus 3, then this bottom side is 2x plus 5y minus 3. If the right side is 5x minus 2y plus 7, then this is going to be 5x minus 2y plus 7. Now, keyword here, let's go back to the problem. Keyword here means that we are finding, okay, the perimeter. All right, so to find the perimeter of anything, you have to add up all the sides. So there's a couple of ways you could do this. What I'm going to do is I'm going to write this whole thing out. So I have 2x plus 5y minus 3 plus 5x minus 2y plus 7 plus 2x plus 5y minus 3 plus 5x minus 2y plus 7. Okay, and then I'm going to go with my highlighter here, and I'm going to go ahead and start with my x's. So I have 2x here, I have 5x here, I have a positive 2x here, and a positive 5x there. So let's go ahead and combine those. 2 plus 5 is 7, 7 plus 2 is 9, 9 plus 5 would give me 14. So I have 14x. All right, next one that I'm going to do are my y's. So I have 5y here, minus 2y, plus 5y, minus 2y. So 5 minus 2 is 3, 3 plus 5 is 8, 8 minus 2 is 6. So I will have a positive 6y. And the last thing that I have to do is just my constants. That's just your numbers that don't have any letters with them. So I have a minus 3, plus 7, minus 3, plus 7. So negative 3 plus 7 is 4, 4 minus 3 is 1, 1 plus 7 is 8. So here I'm going to put plus 8. So this is what my perimeter comes out to be. And that's it. That's all that you have for these notes.